Welcome to the Deep Dives, where we take the sources you send our way and distill them into the most essential, fascinating truths. It's really just a shortcut for you to get up to speed one amazing story at a time. So today, we're going to talk about death, but maybe not in the way you'd expect. We're looking at it not as an end, but as well as the engine of life. I mean, every ecosystem relies on it, right? You have leaves falling on the forest floor, a carcass feeding scavengers. It's all about redistributing nutrients.
Exactly.
But what happens when the absolute largest thing on Earth, a creature that can weigh as much as 33 elephants, dies in the middle of the deep open ocean? We're doing a deep dive into something called a whale fall. And our sources describe this as oasis of the depths, even a transcendental existence.
And that's because these enormous bodies, they don't just disappear. They sink, they settle, and they become the foundation for entire thriving ecosystems that can last for centuries.
For centuries. Wow.
That's right. So for you, our mission today is to unpack that entire timeline. We're going to follow the whale from the surface down to the abyssal plain, look at the 4 distinct stages of what happens next, and introduce you to some of the most unique life forms on the planet.
And these are creatures that have evolved specifically for this one single event.
This one massive, sudden drop of food in what is otherwise a total desert. So before the fall, we really have to appreciate the scale of this life. Whales are the longest living mammals on the planet.
Right. Some live for over 100 years.
Way over 100. And what's just, I find this astonishing, is that there are whales swimming in the ocean today that still have harpoon heads embedded in them from the 19th century whaling days.
No way.
Yes. They are literally living history.
That's incredible. So when they do finally die, I know natural causes and orcas are a factor, but our sources say the biggest threat is still us. It's human activity.
It is. Even with the ban on commercial whaling, they face so many dangers. Ship strikes are a huge one. They cause these terrible internal injuries. And of course, entanglement in fishing nets.
And now climate change is a major factor too, isn't it? Shifting where their food is.
It is. It forces them to travel so much farther just to eat, which burns through their energy reserves. And, sadly, many end up starving.
So what happens then? Once a whale dies, does it just sink?
Not right away, and this part of the journey is pretty dramatic. Initially, the body actually floats for a few days.
Oh, because of the gases building up inside.
Exactly. Gases from decomposition. And this is the one and only chance for surface scavengers. We're talking sharks, seabirds. They all get a quick feast.
And then the descent starts when those gases escape. I read that it can be pretty violent sometimes.
It can be, but once it starts sinking, it tends to travel thousands of meters down and land on the seafloor almost completely intact. And that moment, when it lands, that changes everything.
Okay, so why is that single moment so profound?
Well, you have to picture where it lands. The deep sea floor, the abyssal plain, is basically a nutritional desert. There's no sunlight, so there are no plants.
The only food is that.
Yeah.
That marine snow, right? The tiny bits of stuff drifting down.
Exactly, which is not a lot to live on. Life down there runs on an incredibly tight energy budget. So when a whale carcass arrives, it's not just a meal, it's like winning the lottery for generations.
Our sources said a single whale provides the equivalent of 2,000 years of carbon for that area.
2,000 years is an instant oasis.
That number is just staggering. And we've only really known about this, since the late 80s?
That's right. The breakthrough was in November 1987. A team of scientists was in the Santa Catalina Basin off of California, and they stumbled upon the skeleton of a 20-meter whale. And what they found on the bones themselves was, well, it was a complete shock.
Okay, so let's unpack this discovery. The shocking thing wasn't some huge deep-sea monster. It was bacteria.
It was bacteria, specifically chematotrophs, bacteria that eat sulfur.
They eat sulfur.
They eat sulfur. You see, plants use sunlight to make food, right? Photosynthesis.
Right.
These microbes use chemical energy instead. The fat inside the whale bones breaks down and releases sulfur compounds, and these bacteria use that as their energy source to create food.
And that was a big deal because before this, scientists had only found them in these really extreme places like volcanic vents.
Exactly. Super hot hydrothermal vents and petroleum seeps. Hostile environments. Finding them on a simple skeleton completely changed our understanding of how life could be supported in the deep sea.
Right.
The whole area looked like a mini vent, covered in these white microbial mats.
And they found new species of clams and mussels there, too.
All living off this newly discovered food web. That one find just kicked off decades of research. And what we've learned is that it's not one long decay, it's a succession, an ecological handoff in 4 distinct phases.
Okay, so let's get into those. Phase 1 is the mobile scavenger phase. This is the big feast.
This is the frenzy. It can last up to 2 years. The scent of the carcass travels for miles and draws in all the big scavengers. Sleeper sharks, hagfish, giant crabs, octopuses.
And the cold water is key here, isn't it? It acts like a refrigerator.
A perfect natural refrigerator. It slows decay way down so the flesh and blubber stay edible for a long, long time. And that blubber is the prize. It can be up to 85% of the whale's entire biomass.
So after the big guys have stripped most of the flesh, that mess they make kicks off phase 2, the enrichment opportunist phase.
Exactly. This phase overlaps with the first. All the bits of blubber and tissue that fall off and mix into the sediment that becomes food for the smaller cleanup crew.
We're talking worms, tiny crustaceans, mollusks.
Right. They burrow into the seafloor and scavenge all the leftovers.
And here's where it gets really strange, because this is where we meet the Oasis worm, the bone devourer, or my favorite, the zombie worm.
The zombie worm. Yeah, they are one of the most bizarre creatures out there. They are specialists. They're not interested in the flesh. They go for the bones themselves.
Which are still full of fat, right?
Yeah.
Something like 20% lipid content.
A huge amount. But the worm itself has no mouth, no stomach, no gut.
Wait, so how does it eat?
It's incredible. It has these green root-like structures that it grills into the bone. Then it secretes an acid that dissolves the bone mineral.
So it melts the bone to get the fat out.
It melts the bone. And then symbiotic bacteria that live inside those roots are the ones that actually digest the fat for the worm. It's a perfect partnership.
That's amazing. And their reproductive strategy is just as weird.
Oh, it's wild. The females are the big worms you see. The males are microscopic. They're 20,000 times smaller.
20,000 times.
And up to 100 of them live inside the female's body in her tube, basically serving as a permanent internal sperm bank.
That is just maximum efficiency.
In an environment where finding a mate could be a once-in-a-lifetime event, it's a brilliant solution.
So once the zombie worms and other scavengers are done, we move into the longest phase, phase 3, the sulfophilic bacteria phase.
Right, this is the slow burn. This can last for 50 years, maybe more. This is where those sulfur-loving bacteria we mentioned earlier really take over. They go after the last little bits of fat trapped deep inside the bone matrix.
And as they do that, they release hydrogen sulfide gas.
They do. And that gas becomes the fuel for that chemosynthetic food web. You get these thick, colorful mats of bacteria, green, yellow, white, covering the bones. And that, in turn, supports other life. Mussels, clams, giant tube worms, a whole new community.
And the timeline is just immense. I read that researchers looked at one vertebra, and after 7 years, the bacteria had only gotten a few millimeters in.
Exactly. Another study found the center of a bone was still totally intact after half a century. It's an incredibly slow and efficient release of nutrients.
So this brings us to that stepping stone theory. If these vent-like communities are popping up on whale falls, does that explain how these creatures spread across the ocean?
That's the leading idea, yes.
But the average distance between whale falls is something like 9 kilometers. That seems like a huge distance for tiny organisms to cross.
It seems huge to us, but on the scale of the abyssal plain, which is mostly barren, 9 kilometers is practically next door. Think of them as islands in a desert. An organism's larvae get released into the current from one whale fall.
And just a tiny fraction of them need to survive the drift to land on the next island.
Precisely. It provides a biological corridor, allowing these highly specialized organisms to colonize the entire deep ocean, hopping from one whale fall to the next over generations.
And after all that, after decades, we finally get to phase 4, the reef stage.
The final legacy. This is after all the nutrients are finally gone and all that's left is the mineral skeleton.
So it's not a food source anymore.
No, now it's a physical structure. In the deep sea, most of the floor is soft mud. A hard surface is prime real estate, so the bones become an anchor point for suspension feeders.
Things like sponges, anemones, corals.
Exactly. Brittles, stars, clams, anything that needs a hard place to attach to. And this stage can last for thousands of years. We've seen sites where bones have been on the seafloor for over 10,000 years.
Though I guess this stage doesn't always happen. It depends on the conditions.
It does. It shows we still have a lot to learn. If the currents are too strong, for instance, the bones might get scattered, and you never get that stable reef structure.
So much of this started with accidental discoveries. But now scientists are actually creating these whale falls on purpose.
They are. It's called experimentally implanted whale falls. Researchers at the University of Hawaii, for instance, work with NOAA to sink whale carcasses in specific spots so they can be studied from day one.
That must be a huge undertaking. You can't just drop a whale in the ocean.
Not at all. They have to attach thousands of kilograms of steel ballast just to get it to sink and stay put on the seafloor.
And what have these experiments taught us?
One of the big things is about depth. We used to think you needed the immense pressure below 1,000 meters for this whole process to work.
But that's not the case.
It's more flexible. In colder ocean regions, a fall that's only 100 meters deep can stay stable and support this entire deep-sea ecosystem, which means these oases could be much more widespread than we ever imagined.
And all this research has a huge payoff for us because it highlights the role whales play in carbon sequestration.
A massive role. A single humpback whale absorbs more carbon over its lifetime than 3,000 trees in a year.
Wow.
And when that whale dies and sinks, that whale fall locks all that carbon away in the deep ocean for centuries, where it can't get back into the atmosphere.
So protecting whale populations is also a real strategy for fighting climate change.
A profound one. And beyond carbon, these sites are hotspots for what's called adaptive radiation.
Lightning-fast evolution.
Exactly. Because each fall is a small, isolated, resource-rich island, it forces organisms to specialize very quickly. New species of osedax, new mollusks, new bacteria are constantly being discovered. We're really just scratching the surface.
It's just an incredible story. The death of this giant animal isn't a loss. It's a gift, a colossal life-giving gift that lasts longer than the whale itself ever lived.
It is. We see it go from that initial scavenger frenzy to the specialized zombie worms to the decades-long bacterial mats, and then maybe a 10,000-year reef.
So what does this all mean?
It means that the health of our whale populations is directly tied to the health of the entire planet. By recovering their numbers, we are actively helping sequester carbon in the deep sea. It shows us that what looks like an end is really just a spectacular new beginning.
Which leaves you with a final thought to consider. If these whale falls are the stepping stones that allow life to cross the vast emptiness of the deep ocean, what other hidden pathways might be down there? Maybe huge sunken logs from coastal forests or mass die-offs of squid. What other temporary islands of life are critical to the ocean's health that we haven't even found yet? That's the mystery hidden deep beneath the waves.